All right, Algebra 1 folks, thanks for hopping back in. We have our second Edulastic read through here. This is the comparing data sets. I'm going to hop right in. Number 1 says the frequency distributions of two data sets are shown in the dot plots below. So we have data set number 1, data set number 2. It says for each of the following statistics below, determine whether the value of statistics is greater for data set 1, equal to both data sets, or greater for data set 2. So it's asking you to click one of these. Is the mean greater for the first data set, greater for the second data set, greater for the first, equal for both, or greater for the second? The second one says the median. So look at those, determine, we know how to find the median. Is the median bigger in the first data set? Is it same, or is it greater for the second data set? Last but not least, the standard deviation. Is the standard deviation bigger or greater for data set number 1? Is it the exact same, or is the deviation greater in data set number 2? Consider those. Hopping into number 2, it says Corrine is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. She constructed the box plots shown in the diagram below. So you have 4 of these. I'm just going to point these out. 1, 2, 3, 4 of these box plots here, and it's asking you to consider the following question. Which destination has a median temperature above 80 degrees and the smallest interquartile range? So it has to do 2 of those things. Which of those has a median above 80, right? And you're looking, these 2, this might help, belong with this one. So you're reading those numbers, and these 2 belong with this one. So we're looking for the one that has a median temperature over 80 and the smallest interquartile range. Okay, keep those things in mind. And it gives you the name of all 4 of those. Which one is it? I'm going to get this off the screen, and we are going to move on to number 3. It says, which statistical measure changes when every number in the data set is increased by 10? So does the range change if you bring up everything by 10 in the data set? Does the mean change if you bring every number in the data set up by 10? Does the standard deviation change? Or does the interquartile range change when every data is brought up by exactly 10? Great question to consider. That's really asking, do you understand what those things mean? And when they move, what makes them move or not move? Number 4 says, a gym teacher compares the points scored by 3 basketball teams in their 11 games. The points scored by Team A are shown. So here's their 11 points. Okay, for Team B and C, their points, we don't see them anymore like this. Somebody took a set of 11 games and put it into this box plot, and for Team C, it was also put into a box plot here. So the fact that all 3 of these teams aren't shown the same, it's going to make them hard to compare. Team B and C are easy to compare. Team A is much tougher. What if we take this data and we create also a box plot off our 5-number summary? Think about how we do that. We organize it from least to greatest. We find that 5-number summary. Could we imagine drawing one of those up here? That's going to help us answer these. Which of the 3 teams has the lowest median score? Or is it Team A, Team B, or Team C? It says which of these 3 teams has the highest median score? Third question is which one has the smallest interquartile range? And the last one is asking which one has the largest interquartile range. Some things to consider. Okay, question 5. It says a school has a toy drive for holiday in which students bring in toys to be donated to a charity. The number of toys donated by juniors and seniors are summarized in these histograms. It says, is the standard deviation of numbers of toys donated greater for seniors or juniors? Okay, is the seniors have a larger standard deviation? Do the juniors have a larger standard deviation? Here's juniors, here's seniors, or are they the exact same? Great question to consider. Here we have question 6. The 2 box plots summarize the number of hours spent in the weight room for all players on a football team at 2 different schools. School 1 here, school 2 here. It says, which of the statements must be true about the distribution of spread represented in the box plots? It says, A, players at school 1 are typically spent more time in the weight room than players at school 2. Is that true or false? 2, not true or false. Is that what we can claim? B, the middle half of the data for school 1 has more variability than the middle half of school 2. Okay, something to consider. C, the median hours spent in the weight room for school 1 is less than the median for school 2, and the interquartile ranges for both schools are equal. Okay, something to consider. The total number of hours, this is D, the total number of hours spent in the weight room for players at school 2 is greater than the total number of hours for players in school 1. Can we determine that? Okay, so take which of those can you determine? Look for ones you know we can't determine and get rid of those. Question 7, here's 2 box plots that demonstrate the cost of male and female haircuts based on a random sampling. Females' haircuts, span in this box plot, and the male haircut prices span in this box plot. It says, which of the following statements about haircuts is true based upon the box plots? Check all that apply. A, 75% of male haircuts cost as much or less than the lowest 25% of female haircuts. Is that true? B, the least expensive male haircut is cheaper than the least expensive female haircut. Is that true? C, male haircuts have the largest deviation in costs. D, the most expensive male haircut is cheaper than the median female haircut. Is that true? Take a look and mark the ones, if you think there's more than one, that apply and are true. Question 8. 2 of Ms. Evans' earth science classes have 23 students each. The box plots for recent scores for these 2 classes are displayed. It says, which statement of the scores is true? Based on 3rd and 5th period, the mean of the 2 sets of data are equal. The lower quartiles of the 2 data sets are the same. More students in 3rd period than 5th period scored an 87 or above. And the number of students in 3rd period who scored from 73 to 79 equaled the number of students in 5th period who scored from a 68 to a 79. Okay, which of those is true? Lots of box plots. Here we go. The prices for a set of new tires are, and we have these options. These are what some different people have paid for tires. Take that data, find the mean, find the median, find the mode, find the range, find quartile 1, quartile 2, quartile 3, and find your interquartile range. 2 questions left. This one, the box and whisker plot shows the number of baseball cards collected by 15 kids. It says John collected 523 baseball cards. Which statement must be true about John's number of baseball cards? Is the mode, A, it is the mode. B, his 523 is the 3rd quartile. C, it is in the 25 to 50% range. Or D, his 523 cards is in the 50 to 75% range. Last question. Says the chess club at school has 15 members. The number of games won in tournaments played by the season by each member is listed. Here's all of them. It says, what measure of spread is most appropriate to use to describe this typical value of data in the distribution? If I'm comparing the center, would I want to say the mean, the median, or both? Explain. C, what measure is most appropriate for describing variability in this data set? Is it standard deviation, interquartile range, or both? Take a look at this and determine. Thank you for following this read along. Hop right in or check out the notes.